Okay guys, so we are still solving rational equations. And as you can see here, remember to check for extraneous solutions. That's a thing still. So I'm going to do this. Well, okay, so here's what's up. Unlike the previous assignment, the one side of the equal sign no longer has common denominators. So this is going to take a little more work. Now this video is going to take a little more time than normal because on number 2, I'm going to work it out 2 different ways. The first way is sort of consistent with the way we've been doing things, and it sort of combines concepts together, which is probably a good thing, except that it takes a lot of time and a lot of steps. So I'm going to demonstrate that for you, and then I'm going to show you what I believe is a vastly easier method, and then I'm going to do the rest of the assignment with the easier method. Generally, I don't like to teach multiple methods for the same thing, but this one is so much easier, I think it's going to be worth it. But I still want to go through the first method, which sort of ties different concepts together. So before I start number 2, I want you to realize that this can be treated as a fraction as 2 over 1. So the right-hand side of the equation, we need to combine, and to combine those, we need a common denominator. So the common denominator between 1 and 2n has got to be 2n, which means the second fraction, n minus 1, is not going to change. But this first fraction, the question is, how do we turn a 1 into a 2n? And the answer is you would have to multiply it by 2n, which means, let me squeeze this in here, you'd have to multiply the top by 2n as well. 2 times 2n is 4n. Now, we don't have to make a common denominator on this side because it's not being combined with those. It's on the other side of the fraction, so we can just carry this down. We don't have to make that a 2n. I mean, you could, but it'd be a ton of work and it would not get you anywhere. So over here on the right, we need to combine this all together, and it would become 4n plus n minus 1 all over 2n, which would become 5n minus 1 over 2n. And I would just bring this down. And now we are at the point where we'd go ahead and cross multiply and work this out. Now, in both cases of cross multiply, we have to distribute. So 2n times 4n is 8n squared. 2n times 1 is plus 2n. Get rid of that, all that extra writing. Try to make this look a little neater. Cross multiply the other way. N times 5n is 5n squared. N times minus 1 is minus n. Of course, the equal sign goes in between them. Now, I'm going to subtract 5n squared and add n. Subtract 5n squared, add n. This all cancels out. I get 0. Over here on the left, 8 minus 5 is 3, so 3n squared. 2n plus n is plus 3n. This can be factored using common factoring. Bring out a 3n. You're going to have, what, n plus 1 equals 0. Now set each one of these terms equal to 0. Over here, divide by 3. N equals 0. Minus 1. N equals negative 1. And we have 2 answers. And as we've become accustomed, that 0 answer probably is no good, because when you come up here and try to plug in a 0 to any of the fractions, you're going to end up with, well, here, 2 times 0 is 0. You cannot divide by 0, so that's an extraneous solution. So negative 1 is the solution. Check number 2. And there it is. Okay, so that's good, and if you get that and that works for you, you can do every problem that way. Number 6 is going to be a little bit more of a challenge as far as over here doing a common denominator. Let me just do a quick little note. Don't forget that you would have to factor this. That'd be m and m minus 3 plus 1. So your common denominator would have to have n minus 3 m plus 1 in it. But if you wanted to stop the video right now, say I'm not going to learn this second way, I just want to do it this way, you could do that and go ahead and start doing the odds. But if you want to learn this other method, that's what I'm going to do right now. So let me start this all over. I'm going to erase everything here. I'll leave the answer as a reference. But here's what you do. You do find a common denominator. This time find a common denominator for every single fraction. And even this one. So what's a common denominator for n, 1, and 2n? And the answer would be 2n. 2n is something that all three of these would divide into or cancel into. So here's what you do. Multiply every term in the whole thing by 2n. That's going to become 2n times 4n plus 1 over n equals 2n times 2 plus 2n times n minus 1 over 2n. So I put this whole equation in parentheses, and I'm basically distributing 2n, the common denominator, into the whole thing. Now what that does is it makes a bunch of stuff cancel out. This cancels out, the 2n and the 2n cancel out. That leaves me with 2 times 4n plus 1 equals 4n plus n minus 1. If I distribute this in here, I get 8n plus 2 equals, and then over here I have like terms that can go together, 5n minus 1. Now if I want to solve this, subtract 5n, 3n plus 2 equals negative 1, minus 2 over to this side, 3n equals negative 3, divide by 3, n equals negative 1. I get the same answer and no extraneous solution to plug back in and check. So this method that I'm doing here is sometimes referred to as clearing the denominators. Basically, denominators are what make fractions a pain in the butt anyway. So when you multiply everything by the common denominator, it causes every denominator in the problem to just cancel out. That leaves you with a more linear, regular type equation with like terms that you can just combine and simplify, and it becomes a lot easier. On top of that, you can sort of, once you get good at it, you can sort of combine steps, skip steps, and the work becomes much, much simpler. So this is how I'm going to do the rest of this assignment. All right, number 4. So what's the common denominator for p squared, 4p, and p? Remember, the common denominator has to have all the terms in it. So here, what would contain all of the terms is 4p squared. So that is what I have to distribute into this whole equation. So I get 4p squared times 1 is 4p squared. 4p squared times 1 is, oops, that's the equal sign, 4p squared. And then distribute here, plus 4p squared times 1 is 4p squared over p. Now, what cancels? P squared cancels, but I still have a 4 over there. 4p squared cancels with 4p squared. Now when they're gone, you don't just ignore them. Canceling is dividing. So 4 divided by 4 is 1. P squared cancels with 1p, and it leaves 1p behind. So now, subtract 1 on both sides. 3 equals 4p. Divide by 4. P equals 3/4. And that should be the answer, the only answer, no extraneous solutions, and there it is. All right, let's look at number 6 now. Well, here, another look at this. You can pause it if you need to look at the steps. Okay. Before I do this one, I am going to factor everything. Now, I had done that briefly just a minute ago. And this you might find is kind of a pain in the anatomy, but it's a necessary evil. I'm going to go ahead and put that in parentheses. You'll see why in a minute, maybe. Okay, so this is m minus 3, m plus 1, m minus 3, m plus 1. So what's the common denominator that I have to distribute through this whole thing to clear the denominators? And so common denominator has to contain every factor. So my common denominator would have to be m minus 3, m plus 1. Now, here you could get into a ton of writing, or you can kind of save some steps. So I'm going to try to save some steps, save some writing. If I distribute this all the way over to here, do you see that it's just going to cancel out everything and you get a 1? And when I distribute it to here, it's going to cancel out both of those and you're just going to get a 4. Bring down the plus sign. When I distribute it to here, it's only going to cancel that out and you're going to have this 1 left behind. But you're also going to have, oops, let me do this, a m plus 1, because the m minus 3 cancels, there's still the m plus 1 that distributes over to here. So now 1 equals 4 plus, and then this is kind of trivial work, m plus 1. 1 equals 5 plus m, right? The 4 and the 1 add together, minus 5. Negative 4 equals m. And that should be the answer to number 6 down below. And there it is. All right, number 8, and we are done with the notes. Again, I'm going to factor this before I start, so I can factor out a common r there. Factor out an r, you get 2r plus 1, 1 over r, and then since this is the same as that, they will factor the same, r, 2r plus 1. So what do I have to distribute this whole thing in, or what do I distribute into this whole thing? r, 2r plus 1. If I distribute it to here, both of those cancel out, I just get a 4. If I distribute it to here, only the r cancels out, I'm still left with a 1 and a 2r plus 1. Because that r canceled, that's still there. And then a plus sign, if I distribute it to here, both of these cancel, and I just get 1. That plus sign a little better. So now if I distribute a 1, that's trivial work. 2r plus 1 plus 1. I can of course add 1 plus 1. Those are like terms. Subtract 2 over to here. 4 minus 2 is 2. Divide by 2. R equals 1. That should be the answer. Number 8. Oh, there it is. And there you have it. So these problems I'm asking you to do are going to be very similar to the ones that I did. I kind of aligned them so the strategies here, these two match each other, these two kind of go together, the strategy you'd use, and these two as well. So give those a try, check your answers, show your work. You don't have to show every single step exactly how I did, but you can't just have answers. So you have to show the work that you did for this to count. Use comments or email for questions, same usual thing. And hope you have a good day and find this easy.